Hi there, this is a quick video on how to create your graph in our isotope and average atomic mass lab. And so what I'm going to share with you is an example using the density of aluminum. What you're going to do, of course, is plot your percent abundance of hydrogen 1 isotope and the average atomic mass. So yours is going to be a little bit different, but the setup is the same. So the first thing you want to do after you've collected your data is open up an Excel program. And what I did here is create a nice pretty little data table, but it doesn't have to be pretty. You're not going to paste this into the lab in any way. You already have your data table. The purpose is to just get the graph out of Excel. So what you want to do is create two columns, one for, in my case, volume, which is going to be my x-axis, and mass, which is going to be my y-axis. Yours, again, you're going to have two columns, one that is going to be the percent abundance of hydrogen 1, and the other is going to be the average atomic mass of hydrogen. Right? So once you have all of your data in the table, and again, it's just easier if you set up your table so that the X comes first and then the Y, because of the way we're going to highlight it to create the graph. And so I created my X column here, again, which is my independent variable and my volume, and my Y column here, which is my dependent variable and the mass. And so now I need to create my graph. And so I'm going to highlight all of the data points that I have. Then I'm going to go up to Insert, and then I'm going to go over to Scatter Plot. Now, before I continue with this, when I highlighted, I'm going to do it again, I highlighted X, then Y, and that's how the graph is going to be created in Excel. And so if you had those columns flip-flopped, you'd have to just highlight them in a different order. And so again, it's just easier if you put the X first, then the Y. So again, I have them highlighted. I'm going to go up to Insert. I'm going to go over to this last one here, which is a scatter plot. You could see there's lots of graph options. For us and what we're going to be doing in here throughout the year, the scatter plot is our best choice. And then once you click on that, we're also going to click this first box here, again, our best choice. If you don't and you clicked one of the others, they're going to start putting lines in the graph for you. Some of them connect the dots, which we don't want to do. The bottom two there show really big bubbles for your data points, which kind of makes the graph all clunky and cluttery. And so what we want to do is just pick this first one. So I'm going to click the scatter plot there. And now we have our graph. So now what we need to do is just clean it up and start making sure that it's labeled properly and we get our trend line in there and so forth. So the first thing I'm going to do is label the chart. And so for me, I have two ways I could label this. I could title it Density of Aluminum, because that's what I'm researching here. Or another typical way to label a graph, and maybe the way you would like to name your graph, is to put Y versus X. And so in my case, my Y is mass and my X is volume. So I could title this chart mass versus volume. So again, when you're titling your graph should have a title. You can either use what I did first there, density of aluminum, or you could title it based on what you're graphing, or you can leave both. So typical ways that you label your graph or title your graph. Next up, you want to label the axes. So I'm going to click on the graph, go over to the plus sign, and go down to axes titles and click it. And now we can label our axes. Every graph should have the axes labeled and the units that you used. And so for me, again, the bottom is my volume, and that's in milliliters. And my X or my Y axis is mass, and that's in grams. So again, proper to label the axes of what you've measured and also units in parentheses after that label. The other thing I wanted to point out before I go any further that I didn't say is after you've created your graph, you can always double check that the axes are correct. And so for instance, I want to make sure the volume is plotted on my x-axis. And so if I go up to my volume data, I could see that it ranges from 2 to 10. And I go over to my graph and it ranges from 0 to 10. And so that's most likely my volume, because if I look at my mass values, they range from 5 up to 25, 26. And so my y-axis is going all the way up to 30, which makes sense for my mass data. And my x-axis is only going to 10, which makes sense for my volume data. So it's a way to check to make sure you've highlighted correctly and you have the right data on the right axes. All right, so we have our title, we've labeled our axes and our units, and now we want to add in our trend line. And so again, I'm going to click on the graph. I'm going to click the plus sign and go down to trend line, click it. And then I'm going to go over to this arrow and I'm going to go down to more options. So I'm going to do that one more time before I click there. So I'm going to go up to the graph. I'm going to hit my plus sign. I'm going to go down to the trend line. And you could see now that there's a dotted line on my graph. And what the trend line shows is how good your data is. So let me click it off again for a second. Now there's no line on my graph, but my data kind of looks like it's in a straight line, right? So this is probably a linear relationship. And when you have a linear relationship and you put a trend line on your graph, it helps you to visualize how good your data points are. So I'm going to go back and put it on. And so with a trend line, the closer your data points are to that straight line, the better the data. And so if I look at all of those data points I have, it looks like they're really close or on the line, so I have really good data. And the next thing I'm going to do is hit the arrow button next to trend line, go down to more options, and scroll down, and you want to click the last two boxes. You want to show your equation. That's going to give you your line equation on your graph, and you want to show the R-squared value. And so for what we're doing here in this particular lab, it's not necessarily important that we have that y or line equation or the R-squared value, but it's just good practice to get into the habit of showing it. And so I'm going to scooch it over a little bit. What the R-squared value does is it also shows you how good your data is. And so the closer that R-squared value is to 1, the better the data. So since ours is 0.997, we know that we have really good data. The line equation is helpful for several reasons. So for now that I have an equation that relates those two volume and mass, let's say I have another reading. Let's say I want to know what the density of aluminum is when the volume is 100 milliliters. I can now plug in 100 milliliters for my X value, solve for Y, and now I have a new data point. Right? So once you have that relationship and you have the line equation, you could figure out any data point that you want to for the density of aluminum. The other thing that the line equation is going to help you with is it gives you your slope, which in this case is really important because the slope is the density, so mass over volume. And of course, it'll give you your y-intercept if you needed it. In this case, we don't. But the line equation is beneficial to have there as well. Alrighty, and that's it. And so again, to just go back through, you want to create your data table over here, highlight. You're going to go over to scatter plot, create your graph. You want to make sure it has a title. Make sure the axes are labeled with units. Make sure you have your trend line, your R-square value, and your line equation. And that's it. We're also going to go over this in class together. If you have any questions, let me know.